My name's Peter Wadhams and I'm the Professor of Ocean Physics in University of Cambridge, based at the Department of Applied Maths and Theoretical Physics, DAMT, which is the same department that has Stephen Hawking in it. And I've been working for the last 40 years on sea ice research and polar oceanography and how the changes in the Arctic and Antarctic ice are affecting the world climate. I've run a research group where we work up in the Arctic on using various means, including submarines, aircraft, and walking around on the ice drilling holes. So I've got a lot of experience of the Arctic, really going back to 1970 when I first went through the Northwest Passage.
Could you raise your voice slightly bit more? That's
yes.
Okay. My first question to you is, what are you concerned about what you're seeing? What are you noticing about the Arctic, and are you concerned about it?
Oh, well, it's amazing changes, yes. Just in what you see, apart from what you measure, because I've been measuring ice thickness going down by 50% over the last 30 years. But what you see in the summer, for instance, used to be very heavy pack ice remaining across nearly the whole of the Arctic, so that if you tried to get through it in a ship, you'd have a lot of difficulty. Today, it's more or less like a blue planet in the Arctic. The ice lies so far back in the summer that you have an almost ice-free Arctic Ocean. That's a big change. Another big change is that when you're actually on the ice, working in it, you find that there's very little multi-year ice left. That used to be the dominant ice type in the Arctic. Very thick, very rugged, with very big, heavy, thick pressure ridges, maybe 50 metres deep. The ice itself 3 metres thick, very hard to get through in a ship. Today there's almost no multi-year ice left. All the ice forms in one year, melts and disappears and has to grow again the next year. So that's called first year ice. It's only a metre or so thick, and it looks completely different. It's the actual landscape of the Arctic Ocean has changed completely over the last 30 years.
Do you think this is something we should be concerned about?
I'm sure we should be, and in fact people are concerned about it, because what it's preceding is actual disappearance of the ice, and that's something which could easily happen this year or maybe in the next couple of years. That's disappearance of the ice in the middle of summer, that's in September. That the volume of ice that remains in the summer is now only a quarter of what it was in the 1980s. And if that downward trend continues, there's no reason why it shouldn't do, then the summer volume will go to zero in just a couple of years' time, possibly even this year, which is going to be interesting because I'm going out on an icebreaker this summer. There may not be any ice to break. But that ice-free season, which will start off as being 1 month, will gradually grow until after a few years you'll have about 4 months ice-free, just like we have in the Antarctic at the moment. That's going to be the Arctic of the future, a seasonal ice cover with completely open water during the summer months, and that will have enormous impacts on the various other aspects of global climate.
Do you think, what is the impact on us as a species of this change?
Well, I mean, the impact on the human species of you have to say, are we talking about Arctic change or global change? But I'll talk about Arctic change because that's what I know most about. But the two are linked very strongly because the Arctic is warming faster than any other part of the world, and the changes that are happening there are driving changes elsewhere on the planet. But those changes are going to be the ones that will have the bigger effect on mankind. For instance, the disappearance of ice in the Arctic is leading to warmer air masses moving over Greenland in the summer. That's causing the Greenland ice sheet to melt faster, and that's causing global sea level rise to accelerate. So instead of getting maybe less than a metre of sea level rise this century, which is what's predicted by the Intergovernmental Panel on Climate Change, the accelerated melt of the Greenland ice sheet could give us a couple of meters or more this century. In fact, some glaciologists are talking about 4 or 5 meters. That might be extreme, but it's very likely to be more sea level rise than has so far been predicted. That means we're being very complacent about sea level rise, and we ought to be realizing that many coastal regions, for instance, the coast of Bangladesh, which is very vulnerable, eastern China, and a lot of cities like Miami will have to be abandoned, and that will have an enormous impact on the global economy and on the lives of people. So that's one thing. That's just a minor thing in a way. then the other thing is that global warming itself is being accelerated by the fact that as the sea ice retreats, that reduces the global average albedo, the amount of radiation that's reflected straight back into space, and that means that the rate of warming will go up, so that again this attempt to pretend that we can keep global warming below 2 degrees, which was already a pretense, is even more ridiculous. It's certainly going to get to 4 or 5 degrees by the end of this century, which will then have quite catastrophic impacts on agricultural production, for instance, and being able to support the population that we have now, let alone an increasing population. So that's another impact which people don't think about. And I suppose a third one which I'm concerned about a lot, in fact I'm concerned with doing fieldwork in this area at the moment, is whether or not we might have a massive methane outbreak. We're really concerned about the Arctic offshore, that the continental shelves of off Siberia are very shallow water, and up until recently there was always sea ice over those shelves, even in the summer, because the sea ice didn't retreat very much. Now it retreats in the summer and is already disappears for 2, 3 or 4 months off those shelves. That allows the water to warm up, and when the water warms up, it causes the underwater permafrost to melt, which hasn't melted since the last ice age, and that's allowing methane to be released, because there's a lot of methane trapped in methane hydrates under the seabed. And the fear is that this could all happen quite precipitately, that the melting or thawing of the seabed permafrost will allow a lot of methane to be released in a short time, and that would have a very big impact on global warming. The methane is a very powerful global warming gas, and its impact develops within a very few years, not like carbon dioxide, which is a powerful greenhouse gas but which stays around for a century. Methane does its thing and then vanishes after about 9 or 10 years. But that thing would consist of perhaps 0.6 of a degree extra warming for the planet just within a few years, which would be catastrophic in relation to the amount of warming we've had already and that we're going to get. It's an extra boost to global warming which we could do without, but which we're quite likely to be subjected to.
When do you suspect that this could actually, what is the earliest that this could start to be noticed, the effect of this?
Well, the field workers who are studying the emissions of methane from the Arctic shelves are already seeing big increases in the emission rate. We're seeing big plumes of methane coming out of the seabed in the summer, just like an oil blowout, and gas coming up from an oil blowout. But it's big fields of methane gas being released from the seabed, forming big bubble plumes that are being detected. Now, until recently, all that happened was there was one Russian ship went out there every summer, and the people on that have been seeing more methane being emitted each summer, but only in the East Siberian Sea, which is one of the, in fact I can show it here, the East Siberian Sea is this easternmost shelf sea of Siberia, but we see that there's more shallow seas to the west, the Kara Sea, the Laptev Sea, and ultimately the Barents Sea. So this last year or two, we've had other cruises by a Swedish icebreaker and a Norwegian icebreaker in the Kara and Laptev Seas, and they're seeing just as much methane coming out there as is coming out in the East Siberian Sea. So the entire coastline of Siberia, the offshore permafrost is disappearing, and all the methane that's in there is likely to be released, and so that we need to know how much methane there is and how fast it'll come out. So that ought to be one of the biggest research projects that man is doing, because it's a massive risk. If you do a risk analysis, the risk of a catastrophe is the probability that it will happen multiplied by what the price would be if it did happen. So, for instance, you could justify spending a certain amount of money on detecting asteroids, because if an asteroid hit the Earth, the result will be complete catastrophe. But the probability of an asteroid hitting the Earth in any given year is several million to one. You multiply the two, you get a number which some people would say justifies having an asteroid detection system. But with offshore methane, the effect if it's released on the planet would be equally catastrophic, or almost as catastrophic, because the amount of warming would be immediate and large. But the probability that it will happen is quite large. I mean, it's I would say it's about 50%, because we're seeing the permafrost melting, and we're seeing the methane already being released. So it's not a low probability, high catastrophe risk. It's a high catastrophe, high probability risk, which means we should be studying that intensively and trying to find ways in which we could tap off that methane, for instance, and prevent it from being emitted. Some kind of it's a dirty word, but fracking is a technique that, if you apply it in this context to actually horizontal drilling underneath the methane hydrate sediments, it might be a way of preventing methane from being released. So we should be, on Earth, we should be making one of our highest scientific priorities studying and trying to do something about the possibility of a methane outbreak from the Arctic. And unfortunately we're not, because that's scarcely mentioned by IPCC in its assessment, because I think it's being criminally kind of complacent in not wanting to stress or even talk about the possibility of some major catastrophes. They were once a body that warned the world about climate change, but now they're a body that's trying to say, well, it's bad, but it's not that bad. Just reduce your carbon emissions and everything will be okay. But it won't, because these things are something that have come along. There's enormous evidence that this is happening, and we should be really worried about it. So we should be spending our money on these things, because they could be a very rapid catastrophe for the planet.
Do you have any idea of a way of stopping this?
Well, the only way, as far as offshore methane is concerned, for instance, would be bring back Arctic sea ice. And some people are saying, let's try and do that. But the trouble is, you can't really bring back Arctic sea ice without cooling the planet. And nobody's thought of a targeted method that will simply cause sea ice to grow or not retreat around the edges of the Arctic Ocean. That the sea ice growth and decay is governed by global temperatures. So finding a way to bring back sea ice won't work unless you can cool the entire planet. But the only way that I can think of, or that anybody has thought of, is this method that curiously the oil industry has come up with, which is a modification of the fracking method to have offshore wells, offshore platforms along the Arctic coastline, just in shallow water, and then drill down and have a network of horizontal drilling into cavities or creation of cavities to try to suck in the methane and then pump it out through the well without it actually breaking through the seabed and rising to the atmosphere. So that's no research been done on that. It's just been suggested, but somebody should be doing research on this before it happens. Otherwise, we've really had it.
Is methane, when it dissipates, is it not just equivalent to, say, 27? It's apparently 27 times worse than carbon dioxide. Is it not the equivalent of 27 times the amount of carbon dioxide? Doesn't it dissipate by managing to get some oxygen molecules and therefore reducing our oxygen supply, which apparently is another issue still further, and just becoming the same equivalent in carbon dioxide? In other words, a 27 times stronger carbon dioxide amount.
Yes, well, that's the thing. It is about 27 times as powerful. So every molecule of methane causes 23, I think, times as much warming as one molecule of carbon dioxide. But after about 7 years in the atmosphere, a molecule of methane is likely to be oxidized in the atmosphere, and it turns into a molecule of carbon dioxide.
Just one molecule, or 20,
yes,
27?
It's just one. So it loses its power, really, because its warming power is reduced to 1/27th of what it used to be. So it's when the methane is in the form of methane that it's most dangerous, and when it gets oxidized to carbon dioxide, it's much less dangerous. It's less than 20th as dangerous.
Do you think our children have a future?
Well, only if we take action now. If we don't, I think my fear is that...
Could you say it with the words, I think our children have a future?
Our children have a future only if we take action now. And my fear is that the current generation of world leaders, politicians, I won't call them statesmen because they're not, is too cowardly to take any action now, because any action would involve such a large disruption of our present way of life that they don't want to take it because they might not get re-elected. So there's a conspiracy of complacency throughout the world in which they still imagine that if we do a few minor things and a few minor adjustments and reduce our carbon dioxide emissions, then all will be well. But it won't, because we've already got too much carbon dioxide in the atmosphere. We're already going to have more than 2 degrees warming, even if we don't emit any more because of the already existing carbon dioxide in the atmosphere. So we've got to not only stop emitting it or reduce the emissions, but find ways to take it out of the atmosphere. And that's a technology that hasn't been developed. Would be a massive research program to develop, but we should be doing it. It's a bit like the Manhattan Project. We should be doing it from the point of view of our own survival, and that's the sort of thing that the present generation should be concentrating all our attention on. And if we can do that, then our children have got a future. If we don't, what I can see happening is that we'll see, because climate change has a progressive effect, so that it doesn't hit you today or tomorrow. There's not a sudden, it's not like some virus. It works its way slowly through the world. So you can ascribe some particular tsunami or something, sorry, not tsunami, more some particular hurricane or to random factors. But when you put together all the changes that are going on, you see how they're ramping up to become a major change. And as they go on, they tend to accelerate. Everything's increasing exponentially. So my fear is that nobody will do anything because of cowardice and inertia and all the normal human attributes. They'll sort of say, well, let's wait until it really hits us and then we'll act. But by the time it really hits us, by the time our weather changes have made it impossible to feed everybody in the world, for instance, and we have worldwide famine, by the time those sort of changes of that scale have happened, it's too late to do anything. We will by then have too much carbon dioxide in the atmosphere to prevent a kind of runaway global climate catastrophe. So my fear is that it's that our own inertia will lead us to not take action until it's actually too late to save ourselves.
One last question, or maybe hopefully not, unless you have something else to add. How much time do we have? Like, what if your worst prognosis that Arctic would be ice free by this year was to happen? How early do you think that the changes would be drastic enough for the rest of the world to say, "Oops, we should have done something"?
Well, that's the problem. It won't happen. The world saying "oops," they might say "oops" if all the ice disappears this summer, but they probably won't. The forces of inertia are so enormous. I mean, the use of fossil fuels, for instance, is so built into our society that with the best will in the world, it's really hard to get out of the mindset of using them, and that applies to sort of everything. We've built a society in the last 150 years in which kind of everybody has several hundred slaves at their disposal, which is basically the extra help you get from engines and motors and everything that is produced by burning fossil fuels, and we can't live without that, but we have to try and find ways to do it with other sources of energy, but it's hard and difficult and nobody wants to do it. So the world will likely notice that things are changing, but will still be reluctant to actually take any steps until the changes are so great that they really do immediately threaten our existence, by which time it is too late.
If you were to be elected King Peter of the whole world today, and you could say, don't worry, I think there's something we could do, and they had to do what you told them to do, what would you say right now?
Well, I would say focus the whole, stop spending all of the world's scientific money on military research, which at the moment about 90% of research funds in the world are spent on military research. Take all the scientists in the world and all the funds that are presently spent on military research and switch into studying, first of all, how do we take carbon dioxide out of the atmosphere to reduce, because that's the only way ultimately that will save us, is to bring the CO2 level down. And we can only do that by some drastic method of actually removing CO2 from the atmosphere. We can't do it by messing around with reducing our emissions. We can't even do it by stopping our emissions because things have gone too far. We've got to actually take it out the atmosphere. So I would order the world scientists to make that the biggest research program in the world, and forget military research, forget NASA and so on. Do that. And along with that, do the things that can protect us in the shorter term against specific nasty things which are coming along but are generally disregarded, like a methane outbreak or weather changes which will cut back on food production. We find ways of trying to evolve our methods of food production, or the species that we grow, so that we can adapt to the impact that's bound to happen. In other words, make climate change research, the main thrust of the entire world scientific effort, and do it urgently.
Would you consider it also a good idea to suspend our economies until we've changed our fuel source?
Well, we can't really. That's the thing. We're trying. We want to be able to feed everybody on the planet, and much of agriculture is industrial. We've got 8 or 9 billion people because we've industrialized agriculture, and that requires at the moment fossil fuels. So we can't suddenly switch off. We've got to. The only way we can, then that's why I'm saying we have to take carbon dioxide out of the atmosphere, because all the ways that people have proposed to gradually modify the way we live such that we live more sustainably, they will all take time to happen, and they're taking so much time that they haven't even started. But the threat from carbon dioxide is immediate. It's there now, so we have to deal with that. Which means a science and technology hitting it. I mean, people have said, well, this is terrible, this ideas of geoengineering or carbon dioxide removal, because it's giving us an excuse not to do anything about reducing our carbon emissions and leading more sustainable lives. And there's some truth in that, but the trouble is the timescales are wrong. We should be leading more sustainable lives, living in a better way, in harmony with the planet, etc. But it will take decades to do that, and we haven't got decades. We have to use a technology-based approach to get rid of some carbon dioxide out of the atmosphere, just to save ourselves from a complete catastrophe.
The feeling of a great catastrophe, could it happen as close as 2-3 years' time?
Well, we'll see. I think in 2 or 3 years' time we'll have seen some changes that are visible. Like, I think the summer sea ice will have disappeared by then, and we'll see an increase or a continuing instability in the weather systems of the planet, which seem to be related to sea ice retreat and warming of the Arctic. So all of these extremely weird winter weather systems we get in Europe and North America, they'll continue and maybe get worse. So there'll be a gradual worsening, but I think when things are gradually changing, even if that gradualness is quite rapid, you really don't notice anything in a single year. And I think it will, by 10 years' time, we'll be really in the soup, I think.
You're going to the Arctic now. What do you propose to do, and what are you hoping that you won't find or will find?
Well, at the moment, we've got a research cruise in the Arctic Ocean in September with a new US icebreaker at University of Alaska. And we're looking at one particular thing, which may not be the most important thing, but it's that the retreat of the sea ice is in summer is going much faster than computer models predict. And we think that one factor there is the fact that as the sea ice retreats, it opens up this huge area of open water in the Arctic Ocean, which is then becomes like an ocean with lots of waves and storms and swell, and the waves themselves break the remaining ice up and cause it to retreat faster, so that there's a kind of collaborative effect there that the remaining ice is vanishing faster because of so much open water is producing wave action. So one thing I'd like to mention, which is positive, is the forthcoming encyclical by the Pope, which is going to be published on Thursday, which I think is called Laudato Si or something. It's encyclicals. I mean, if we're thinking about politicians and statesmen and the actions that they could take, there are very few politicians that have any credibility these days. This is an era of really poor quality politicians. It's a bad time for the planet, But the only person who really retains enormous respect and has a huge power base in the world is the Pope. And the fact is that he is extremely concerned about climate change. Last year, he had a conference at the Vatican, which I went to and gave a talk at, which was a bunch of climate scientists were invited to talk about how rapidly things are changing in the planet, what can we do about it. That was the Pontifical Academy of Sciences. So that meeting and the aftermath, the continued interactions between the scientists and the Vatican has led to the Pope really developing a very powerful encyclical about climate change, what we're doing to the planet, how bad this is, and that we should be doing something about it urgently. And that's about to come out this week, and I think that will have a lot of power, because already it's producing kind of anguished expressions of denial from Republican presidential candidates in America who are Catholics. That they could previously reconcile being a Catholic with being super keen on oil and all the nasty things that pay for them being politicians. But now they've got to have a real difficulty when this encyclical comes out. They have to decide whether what comes first. So I think it's already, before it's even published, it's having a beneficial effect. So there's a few glimmers of hope, and one of them is actions taken by people who have unquestionable moral status in the world, like the Pope.
If we took drastic action before the end of this year, what do you estimate our chances of reversing this situation?
Well, if it's really drastic, then I think we can. We won't be able to avoid 2 degrees of warming, but we can maybe stop it if we can develop CO2 removal. We can stop it before it gets to, say, 3 or 4. So we can gradually bring things under control, or at least reduce the rate of warming to the point where it is possible to adapt to it. At the moment, it's accelerating to the point where we can't adapt. But so I think if we take really serious action, and it has to be really serious now, that we can sort of survive.
Thank you very much.
Okay.
Thank you.
Okay, pleasure.